Hello YouTube. One of my viewers contacted me about helping him with his hydro system, so I've been working on that. Let me show you what I've got and what I've kind of been working on in the shop just a little bit. And I hope this satiates your hunger for more hydro videos, as they do satiate my hunger for that. This finished printing yesterday. It is a impeller. This is just my, what is it, a SainSmart Ender 3 Pro. It's not even the new one. It's a little bit dusty, even though I have it in this enclosure, because my shop, I don't really have very good dust collection. So every time I start a new print, I need to wipe off the print bed. But it works flawlessly. I haven't really done anything with this printer in a year and a half since I got it. The only thing, literally the only thing I did is I replaced the magnetic bed with this glass bed. That's all I've done. And then part of the dust, man, look at this. It's got like a good inch of snow there. More working on countertops for our business. Got a really nice smooth corner here. Use my CNC router. I cut out a template to do that. Let me show you some of his videos that he sent me. Oh, wait. Huh. Interesting. So I've got a few videos that I will transition to here. This is his video that he sent me when he first had a hydro system set up. It's about 6 square miles of drainage in Georgia, and this is actually the top of a 5-acre pond. Right now he has, or had, 2 stacked Vortex turbines that weren't producing as much as he wanted, and there's a washing machine motor that he has converted over to direct drive, or generator use, you could say. Not really direct drive, it's belt drive. So he wanted something that could do a lot better with what he has. This is kind of a medium-low flow rate for his system that he's showing us. It does flow the whole way around there. He's shooting for around 500 gallons per minute continuous flow, falling about 8 to 9 feet. It really depends on what the water levels we're going to achieve flowing through the system. And we're going to transition it to an inline impeller system, which I guess would be called a fixed pitch Kaplan style turbine. And so you saw the 3D printed impeller that I'm going to use. And we're going to replace all of this, and he's already ripped all this out and replaced it with a different tube system. Underneath his walkway here is a chute. He has a 7-inch riser around the perimeter of this overflow culvert, and we're going to tie into this chute right here that's going to go right into the large cylinder on the left that's going to be lowered down. This is the gate that I was talking about that the water will enter in through. You can see at the top of the gate we have about 110 inches of head available to us. Here's what he took out. This was the cone underneath his Vortex, and this is what I proposed to put back in, at least an early revision of it. Again, this is an early revision that we did not go with because he had an excellent idea. This is the suction tube that the turbine's going to go in, and here's the turbine that I modeled up and sent to him for approval. This is the shaft coupler that the turbine will mount on, and here's that suction tube installed in his drain pit and flowing some water. I don't know if he has it turned on here. And then this is, I apologize for the crude video, this is what it looks like flooding after a heavy rain. He's not very technologically savvy, so this is the best way that I will be able to convey this video for the time being. I did modify the impeller different from that drawing that I sent. It's a little bit shorter in elevation here, and that's just to reduce the amount of plastic and time it takes to print. The original print estimate was over 2 days to print this out, but as it is, it still took 32 hours, I think, to print this out on that printer. This is PLA material. It should be plenty strong for the purpose. Seth Johnson at Land to House, he is testing out a turbine that's smaller than this. This is 6.04 inches or 6.4 inches. So the one that Seth is testing out is a 4-inch turbine, and it's estimated to flow around 100 gallons per minute. This 6-inch turbine is, I'm hoping, flowing at 500 gallons per minute, which I estimate at about 40 watts per foot of head. So if we can get the full, if we're optimistic here, 110 inches, that's going to be, damn, all this math. I'm hoping that this will make, 400 watts at 900 RPMs based on the pitch and stuff that I have. You can decrease the load on the generator so it spins faster. You'll flow more water up to a certain fluid friction limitation. You will get more power the more gallons per minute you flow, and he will get more voltage out of his generator, but he's going to be using a Midnight Solar Classic, which is like the gold standard for this sort of thing. So he'll be able to take higher voltages up to 200 volts input. If this is flowing at 1,000 gallons per minute, it should be approximately close, double the power output. So 800 watts. And that would be 1,800 RPMs shaft RPM on this. Now, he also has that gearbox, so if he does need to run faster RPM or lower RPM, he can change that, but we have a large working range with the generator that he got. He got the same generator that I have for my turbine. It's so he has the same turbine that I have, the ME1603 by Mote Energy, MOT Energy. I don't know what it is. In August or September, we're going on a family vacation down to Hilton Head Island. Haven't booked it yet. But hopefully, with any luck, we'll be able to see this in action. Or at least I will in person, and you guys will see it through a camera. So we'll see where this goes. I'm going to have more update videos on this in the future. So make sure you're subscribed so you don't miss those. And if you have any other comments or questions, or if you're interested in doing the same thing, I have my email at the end of the video. Just email me. I try to get back to all of them, and maybe we could work something out. Just to be clear, he is paying me to help him design this and supply this. It's not very much money, actually, and I've spent way too much time on this, probably only making like $3 an hour, $4 an hour. But that's okay, because you guys know that I enjoy doing this sort of thing. Okay, I'll see you guys around. Bye.